Hello everybody, welcome to Marketing Analytics course. This is Dr. Shagata Chatterjee from Vinod Gupta School of Management, IIT Kharagpur, who is taking this course. We are in week 4 and we are discussing demand forecasting and pricing. So, till now we have talked about a little bit of pricing and we have talked about demand functions, and now in this particular class I will discuss about how to use analytics to forecast a demand. So, in your data set you will have a file called computer I would say sales.excel file. So, sales.excel file will have a data set which looks like this, which has, if you carefully see, that it has year component and then the timestamp. Timestamp means whether it is not timestamp actually, it is a time period component, and the month and the sales. So, for 2016, from 2016 till 2019, I have 4 years of data and I have monthly data of sales of something, and the timestamp is nothing but the month year combination of that. So, as TS increases, you come closer to the current thing, and now our job is to try to estimate what this particular thing is, how I can forecast the next demand. So, what happens is, in real life situation, what happens is that if you have xt, xt is considered to have 3 components. One is trend, which is TT, plus one is seasonality ST, and then ET. So, there are lots of ways of actually estimating a time series, but here we will be focusing on the simplest way, where we will break this particular thing into 3 parts. One is the trend component, one is the seasonality component, and one is the error component. So, trend, what is trend component? So, let us say if I have a time series which looks like this, if this is the time series, you can easily see that I can plot a middle value which goes like this, the dotted one. So, this is the trend, the overall I would say function of this particular thing, whether it is going up, going down, going up and then coming down or something like that, that is trend. And then, so a little bit of less undulations are there. And then seasonality is more related to certain patterns which come back after a certain period of time. For example, let us say the sales of a cold beverage is going up. Why? Because population is going up, and if population is going up and their purchasing power is going up, then the sales of cold beverage will go up over years. So, that is something that is a positive trend. But in the summer season, the sales goes up much higher than the winter season. So, you will see that within that going up, within the sales going up like this, there will be a jump in the summer season and a little bit deep in the winter season, and again a jump, again deep, again a jump, again deep, and so on. So, that part is called seasonality, where the pattern actually repeats itself over a certain period of time. So, when this particular seasonality happens for a very large period of time, we will call it cycle, which is generally we do not use to forecast, because forecasting is generally done for a shorter period of time, and then the trend is like this. The rest of the part is error. Now, this error part is something which your time series cannot explain. What is time series cannot explain? What does that mean? That means that, for example, let us say if I ask you that how much will you score in a maths exam which will come in the next 2 months. The best bet of your maths exam score that will happen in last 2 months, in the next 2 months, is whatever you scored in the last 2 months probably. So, what I am trying to say is that your recent past performance of maths is the closest predictor of your recent future performance. So, similarly, for any time series, there are some part of the time series is past which explains what will happen in the future. So, that is the part where we do time series analysis. That trend is how it actually talks about how the past of this particular observation is going to affect the future. And seasonality is also related to how the past, not exactly past, how the time will impact the changes in the x variable. But other than my past, other than my time factor, there can be so many other factors which are cross sectional, which is at that time period, which might impact my performance. For example, let us say in case of your score in maths, probably your health, whether you are okay on that particular day or not, will actually impact your performance. So, that is the component, all those components are stored in ET. So, if there is no such component, if absolutely there is no such component, then this ET will have a mean value of 0 and absolutely, but if by chance that if there is certain things which might impact, then you have to find out x t minus t t minus s t, which is E t, and then you have to find out E t as a function of various stuff. For example, let us say in this context price. So, price at tth time period, price of the product and price of the competing product p dash t. So, all of these things might impact, and this is where the demand function actually comes in. So, you if you get a trend and seasonality, let us say from this data that we have is a sales data. Now, this sales has happened because of multiple reasons. Something is actually related to its past sales. So, if I remove that past sale component, the whatever effect of past sales on present sales, if I remove that component, and if I also remove the seasonality component, that okay, in certain seasons the production goes up, that is why the sales goes up, I will actually remove those part and then I will keep the rest, where the time factor is not anymore affecting, I will get some error. Now, by chance if I also have some price data here for every time period, price of the product and price of the competing product. So, price let us say something like this. So, if I have this data, these two columns, then what I will do? I will try to find out how the error part, whatever is remaining, is related to this price. So, I will do a regression on the error with price and price dash as my independent variables, and I will try to create a demand function out of it. So, before I do that, I have to do the find out how to remove the trend and seasonality component of a data set. So, that is something that is more important to do. So, what I am going to do here is the first job is to try to plot it, and the plot looks like this. So, I can easily see, at least in this particular plot, that you can see that okay, so there is a pattern that okay, it is 8, let us say, and this one is around 18. So, 8 to 18, 11 is something that they are coming back. Now, this is 18, I will expect if this is 29. Okay, so, then here also you will see that the jump is 11, and then if it is 29, then this one is 40, okay, 41. So, I can say that 11 or 12 is something where the pattern is repeating itself. Now, then you should not only see the picture, you should also focus on the common sense. So, okay, it is monthly data. So, probably it is not 11, it is 12 is the. So, it is only because of these 3 years I got 11, but probably it is a 12 number of months actually which creates the seasonality factor. So, what I will do is I will know that okay, so this guy has a seasonality of 12 months, something like that. So, one good job is to do that. Okay, so, I will create, first thing is I will try to find out the trend. So, the easy way to find out the trend is to do a smoothing. Now, you can also see that 7, here it is 8 and here it is I think 10 and then here it is 13 and then this one is probably 16 and this one is 18. So, 2, 3, 3, 2 and then this one is let us say 18 to 22, 4 and then this one is probably another 22 to 3, 25. So, average 3. In average 3 there is a small jump and coming down, small jump and coming down, small jump and coming down. So, I can also think about that as my seasonality component or something like that. So, keeping that in mind, I will be finding out the trend. The easy way of finding out the trend is something called simple moving average method. What is simple moving average? Simple moving average is saying that okay, so average of these 3 terms. So, average of one point earlier, now and 1 point later, something like that. Now, here I have chosen the time period for the simple moving average is 3. You can choose as 5 or 7. By chance, if you do choose even number, then you have to do double smoothing, 2 times you have to do the smoothing. So, once with the even number and the second time with 2 as your time period. But if you do odd smoothing, then you are more or less safe, that it is centralized. So, I will go ahead with doing with odd number. So, 3 is the thing that we chose by seeing that curve. So, 3. So, because there is no past data for this particular cell, this is remains blank, and because there is no past data for this particular cell, this also remains blank. So, these are the 2 values that remains blank. Now, if I just try to plot this table, whatever I created, the simple moving average table, if I try to plot, you will see that it is a little bit of smoothened version, the undulations has come down. But this looks very beautiful, that it goes up and comes down, goes up and comes down, goes up and comes down. In the SMA itself, in the I would say in the moving average itself, there is a seasonality component that is there, that is number 1. Now, if I find out the error, so how much did I do mistake, how much I could not explain, that is nothing but this minus this, something like this, and then if I just drag it up, it is like this. Now, if I just try to plot this part, which is the part which I could not explain, it looks like this. So, this is very I would say peculiar. So, if you see that this particular guy has it is more or less the average value is 0, more or less it has come down to the average value, the trend value, the trend component, the increasing or decreasing component is not there, but there is a seasonality component that is there, and I think the seasonality size is almost 3. So, every 3 time periods there is a jump and coming down. So, you will see that this peak, this lower is 0.7 and this lower is 0.9 and this lower is 12 and then this lower is 15 and this one is 17, this one is 19. So, almost 2 or 3 something like that, this one is 21 and then this one is probably 24. So, 2 or 3 is something where things are repeating itself, zig 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 zig. So, I can take also 2 or 3 depending on the situation. So, let us go ahead, because there are lots of, so for example, 24, this is 26, this is 28 and this is 30, this one is 33. So, I can take also 2 probably as my in the picking up. So, how much will be the every jump? So, let us do that. Now, there are 2 jobs, one is to find out the seasonality component and another thing is to find out the SMA, how I can estimate this SMA. Now, carefully see, if I do the first job first, that if I try to create a function which will define what this SMA is, I will pick up this time series, 2 time series components. So, time stamp, or let us say I will pick up the whole thing here and I am pasting it as special. Then if I just zoom it up and I remove this, because this is the part that I do not focus on, this is the thing that I am interested in. So, I can do a regression on this one, I have to find out a linear equation. So, I can do a regression, or I can easily just simply do a time series component. So, let us do a regression and I say that okay, TS is 1 to 48 and TA timestamp is a numeric variable, and one job of this thing is to do a let us say if there are 12 time periods. So, 1, 2 and then 10, 12. So, I will put a value of 1 here, all of these values are 1, let us say. Okay. And I will see that okay, so if the predicted value here is, if this value is 1, so if this, I will actually VLOOKUP this month value, this small table, and I will put F4 because I will drag later, and then 2 comma false is take from the second column and I will drag it up. So, all ones because they are. Now, what is the error part? The error part, how much is error remaining after this thing? Error is nothing but basically or error square is this minus this square, that is the error square that I got. And what is RMSE? RMSE is equal to basically square root of mean of or average of, square root of average of this particular column. So, I got the RMSE. Now, I have to find out such values here such that this minimizes. So, what I will do? I will go to the data solver, I will minimize I15 by changing what? By changing these values, and these values now can be negative as well. So, not positive, and solve, and the solution is giving me something, and carefully see what is the solution giving. So, the solution is saying that this is the thing that will repeat itself. This is the thing that will repeat itself, and how the repetition looks like. So, this particular table, so 1 to 24, this will go on repeating itself, and you will find out this thing. So, if you remember, the table was the actual SMA values were this, the actual SMA value. So, if I just draw two lines, this is the actual series one is the red line, which is the actual line, and the red line is the one that I predicted, and they are more or less same, they are pretty good in terms of the predictions. So, I can say that okay, so this particular thing can actually talk about the trend part. So, this is something that is done, that I can find out. I can also run, if you want, you can run a regression equation with timestamp minus 12 as your variable. So, this minus 12 or this square as your x variable, and try to predict. Now, this is how I am trying to predict the trend part, how the trend will look like. So, if you ask me that okay, what will be the trend component here, I will find out okay. So, this value is 12, whatever value is corresponding to 12, put that. Okay, so, the value is 650. So, I will just drag it up for the next probably 12, and then again 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So, next 1 year's data I know that this one will be the trend component. So, this is something which I know. Now, next component, now the problem with this model is that I am saying that the trend is same, fixed, there is no going up or going down. So, sometimes we prefer, that is why I am saying that you can also run a regression equation. Regression equation will give you a movement, but it will be slightly going up. So, you can actually, instead of doing this, you can actually do this one as well. So, you can probably delete this and try to find out SMA as a function of this time series component. So, if you remember, it went up and then came down, and then again went up and then came down, and so on. So, I can use this month one and then timestamp both as my x variable, this 2 is my x variable and this is my y variable, and try to predict that, and that will also give me some kind of solution. The problem is that here you have to treat these values, the month values, as categorical variables. So, you have to open it in a R file, change this one to a factor variable, and then run the regression. This is your y variable, this timestamp is your x variable, which is continuous, and month should be a categorical variable, because month 1, month 2, month 3 is actually January, February, March. This has to be treated as factor variable. You can find out a equation for your trend component. Now, what is to do about this one, the error part, which is now here, what is this error part? The previous slide. The previous slide error part is we have actually already considered the. So, we have considered, as I told, x t is equal to what? Trend t plus s t plus e t. So, what is that? X t minus trend t is actually seasonality and error part. So, this is the part that I will focus on, the seasonality part and the error part, and I saw that the seasonality is either 2 months or 3 months or something like that. So, I can do the same thing that I did earlier. I can say that okay, this is of 3 months and the values are 1, 1 and 1. You can try out with 2 months also. I do not know which one will give better result. The methodology is same. So, I say that okay, VLOOKUP, basically I have to repeat this particular value every 3 months. So, if I have to repeat this particular value every 3 months, I have to divide it by 3, this month I have to divide it by 3 and try to find out. Okay, so, the time stamps for example, this time stamp I will actually divide it by 3 and I will find out what is the remainder. So, what was that? So, remainder is probably so, if I am not wrong, which is how to find out the remainder, mod returns the remainder after a number is divided, mod of this by 3. Okay. So, this comma 3 basically, this comma 3. So, that gives me the remainder. So, see 120, 120, 120 gets repeated. So, this is the season component and I am saying 120, these are my 3 seasons, and I am saying that VLOOKUP of what? VLOOKUP of this particular value, the season value, for this one it is, this one is value, and then where in this small table, and I have to put F4 because I will actually drag it, and then 2 comma false. So, that gives me the values, and if I just drag, everyone comes 1, the last value will be not there. So, this is my predicted seasonality, predicted season, and what means the error now? The error now after seasonality. So, error 2 is nothing but basically this is what? Is this square it up? No, I have not squared it up. So, basically is equal to this error minus this predicted square of that. And then how much is the RMSE? The RMSE is nothing but the square root of average of this particular column, not the 0 one, not the last 0 one. Okay. So, if I just do that and press an enter, I get the. So, what is then? I have to again optimize this RMSE. How to optimize? I will go to data, click on solver. Okay. And the solver saying that okay, this is my reference cell, and which one I will change? I will change these 3 cells and unconstrained. Okay. So, solve, and it gave me solution, and it told me that this one should be the seasonality 5, 19 and minus 27, and this is the predicted values and these are the actual values, and now RMSE is coming as 65. You can also try out with 2 time periods and see that whether the RMSE is coming up further lower. And if I just try to plot these 2 and see that how good it is, I will see that okay, not so good probably, I should have a better option than this one. So, I have to find out whether some other variables is predicting better or not. So, probably 2 time period or 3 time period, 2 time period is something probably might work better, you have to check that. For example, how to do that 2 time period? The simple thing is, if I just change it to 2, then this one will be 1 and 0. So, I remove this and then I put this as here 1 and 0, and then what is the VLOOKUP of C3 in K3 to K2 to L3, 2 false. So, this part remains same, okay. And then the error also remains same, RMSE remains same, and then I will run the solver once more. 65, if you remember, the previous one was 65 or something like that. Solver, solve it. So, L2 to L3 solves, and now it went up actually, it did not work well. So, I will go with the 3 time period only, and if I just see the picture here, the picture is coming up to be something like this, which is worse, the previous one was better. So, something like this you can do to find out the undulations. Now, there can be other things, these undulations, the one that we could not predict, which is still remaining here, the square of that is still remaining here, can be actually predicted by many other factors. Not everything is actually coming from your past. So, you do not have to worry if there is something which is still left after removing out the seasonality component and trend component. That remaining part is something that you try to regress on price or let us say something else. So, what we do is in that case that we try to find out this that okay. So, now I have found the seasonality component. So, I say that x t minus t t minus s t is equal to E t. This should be something like it should look like this, where it's no trend component is there and some. So, absolutely this is a 0 thing and it is actually distributed over 0. Now, what are these particular spikes? Why these spikes are coming? What I will do is I will write E t is probably alpha plus beta 1 into P t, my price, and then beta 2 into P dash t, someone else's price, and so on. And then if I have, let us say, advertisement expenditure, if I have price, if I have probably some other kind of promotions going on, all those variables will now come in after the time series component has been taken care of. All those components will now come in to the predictions. There can be also some things where you can say that okay. So, there were cases where we see that the sales actually is not only related to current pricing, but also related to past pricing. For example, let us say during the festival season, before the festival season or during the festival season prices goes up. Before the festival season, they give huge discounts, 50% discount in pantaloons and let us say Big Bazaar and here and there, lots of huge discounts, and if people go and buy Big Billion Day. After Big Billion Day, you will see for a very long period of time, probably 1 month or 2 months, there will be a dip. So, the sales is very high in Big Billion Day or etc. will actually impact the sales later, because people has accumulated or stored lots of stuff and they have created their inventory and they will not buy. So, you can say that the pricing at t minus 2, t minus 3 time period is actually affecting your current sales. Also, the sales at that time is actually affecting the current sales. So, those kind of factors are there, that those are econometric issues, that whether the price of 2 time periods back is independent variable or the sales component is an independent variable. But in general, if I actually remove the sales part, if I remove the seasonality part, then I generally do not have an issue. There are other methods where here if you see, I am only considering the past effect of 3 time periods at max, but there can be a case situation where the sales of the current time period is dependent on the sales of 3 time periods or 2 time periods back. So, we can also use concepts of ARIMA. ARIMAX is actually a classic example. ARIMA part is the part where you take care of the component which is the time series component, you remove all of those stuff and then you also include the cross sectional component in the x variables. So, that is also something can be used in forecasting. We are not actually focusing on that part, because that is something which itself is a course, that the time series forecasting and etc. will itself is probably a 20 hours 30 hours course, and it will actually overshoot our this particular course's purpose. So, that is why we are not going to that, but this is something that is very basic, anybody can use it and any context and can get fairly good result. So, by saying that, I will be meeting you in the next video and we will talk about a little bit of a different kind of forecasting in different situation. We call it Bayes diffusion model. I will see you in the next slide about that. Thank you very much for being with me.